This is an example in math where if you just stop for a moment and don't let the problem overwhelm you, what you're going to find is it's actually a pretty straightforward process. We're being asked to take the derivative of the antiderivative, and for the first time ever, we start seeing an equation in our bounds, a number we're used to on top, but we're not used to an equation in our bounds, and then t over 1 plus t squared. All of a sudden, the variable on the inside here is different than the variable on the outside. When you see this happening, this has got to be bells and whistles going off in your head that this is the Fundamental Theorem of Calculus, Part 1. So Part 1 gets named first, but the one you use the most is Part 2. That's really your definite integrals that you've been playing around with a lot. The Fundamental Theorem of Calculus, Part 1, it's a little definition. It makes sense once you think about it. What you're essentially saying is if I take the derivative of an antiderivative, and this format here always needs to go from a number to x, to some function of x up top here, of some equation, well then out of there, guess what happens? The derivative and the antiderivative, they cancel each other out. It's like squaring a square root. They cancel each other out, and what you're going to get is that x value is just going to pop down into your equation here. So you're just going to get out f of x. So derivatives and antiderivatives cancel each other out. So I look down here and I say, dang, that looks really close to what I need, except for the fact that I need the number to be on bottom and that function of x to be on top. So the first thing you have to do in this scenario is you need to reverse the bounds. So I call it pulling an x. Whenever we need to adjust our bounds here, you put a negative into the front, and that allows you to flip your bounds. So I flipped my bounds on this. Everything else stays the same. And now I'm coming through and I'm going to ddx this equation. So I'm going to take this derivative. So derivatives and antiderivatives, they cancel each other out, right? And then this sign of x is just going to flow down into wherever I see a t. The key on this though, so that's the first part of this is, okay, that's simple enough. I got my minus sign, and then instead of t on top, I plug in the sign of x. And instead of t on bottom, I also plug in the sign of x. And this time it would be squared. Whenever this becomes something more than an x here, though, up on the top, now what you got to remind yourself of is you're really doing a chain rule. So you took the derivative of that piece, and you also need to multiply it by the derivative of that piece on top. So the derivative of sine is cosine. So when we're doing the fundamental theorem of calculus, when we take the derivative of our antiderivative, they cancel each other out. But we can't escape the fact that we're doing a chain rule, really. And so while we've taken the derivative of the outside piece, we also need to multiply by the derivative of that piece we're plugging in, that sine x up at top. So whenever we're doing these problems, just remember to also multiply by the derivative of your bound. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.